Hello, everyone, and welcome to our webinar, Agentic AI, Use Cases, Benefits, and Risks. This is Michael Hoard, and I'm the host and facilitator for today's discussion. I serve as chair for the SNIA Cloud Storage Technologies community. Today's conversation is with Erin Farr, Senior Technical Staff Member for the Storage CTO Office at IBM. Hello, Erin. How are you today?
I'm good, Michael. How are you?
Awesome. It's great to have you on the webinar for this important topic. And before we get started, I want to mention that the CST community is one of the groups within SNIA responsible for education and raising awareness on topics like self-storage in a world of AI ML workloads. Additionally, the CST has helped organize and complete 2 SNIA Cloud Object Storage Plugfests, and that's highlighted in our recent webinar, Community-Driven S3 Compatibility Testing. We are preparing for our 3rd Cloud Object Storage Plugfest to be hosted at SNIA Developer Conference, September 15th through the 17th in Santa Clara, California. Please join the CST and other SNIA groups to help organize and promote these important activities. Next, I want to mention that SNIA is a group of about 200 industry-leading organizations comprising of 2,000 active contributing members and 50,000 participating IT end users and storage experts worldwide. SNIA develops global standards and delivers education on all technologies related to data. Now I'd like to take a quick look at the SNIA legal notice. This provides SNIA's copyright notice regarding use of the material. There are no warranties expressed or implied, so if you want to reference this material, please do so at your own risk. You can download a copy of this presentation using the interface for this live webinar. The interface also allows you to submit questions during the talk and rate this presentation at the conclusion. We really appreciate your questions and feedback. If we are not able to cover all the questions during the session, we will answer your questions in a Q&A blog, which will be posted after this webinar. So let's get started. Erin, please take it away.
So I'll first quickly just take one page to talk about how Agentic AI is a market disruptor, and then I'll go into detail about what Agentic AI is and how we all got here. I'll cover aspects to think about when looking at enterprise use cases. I'll provide a sample use case that I implemented earlier this year and do a live demo. But many of you have heard of model context protocol, so I'll cover that a bit along with its implications. But my goal is that by the end of this talk, that you walk away with practical considerations when assessing Agentic AI solutions for enterprises, whether you are building them yourself or consuming them from a vendor. So at a high level, with Agentic AI, we are moving from AI that can create for you to AI that can do for you. And if you haven't been disrupted by Agentic AI yet, my guess is you will be soon. This slide is here to maybe convince you of 2 things. It's Wild West and it's happening. I personally feel like Agentic AI is more disruptive and advancing at a faster rate than when generative AI came about. As you can see, some of these stats are conflicting. Like one says agents will become core to operations in the next 12 months, while another says companies will have launched pilots by 2027. However, the investment is real. Investors have poured over $2 billion into Agentic AI startups, focusing on the enterprise market. And there's other reasons that it's Wild West, right? There are numerous frameworks for building AI agents and protocols for connecting things, and they're all competing for adoption. And if you've done any research at all, you'll see a moderate amount of conflicting information, like different definitions on the meanings of terms, including Agentic AI itself. So I'll try to call that out as we go along, but please don't get hung up on that during the session. The goal for today is to articulate what it is and what you might want to think about. So how did we get here? Right. So in 2002, you might remember LLMs burst onto the scene with ChatGPT. As a reminder, LLMs are simply models that predict the next word. and they're limited by what they're trained on. So for example, if you were to try to ask it a question that relied on understanding upcoming weather, it would hallucinate. So to offset that, instead of trying to make the model good at scenarios it wasn't good at, people started to design systems on top of and around the model known as compound AI systems, such as RAG. And these provided a way to infuse new knowledge without retraining the model. But then people started to wonder, instead of AI responding to a question, can AI accomplish a task? And this led to Agentic AI, which is a program whose execution logic is controlled by an LLM. So now, instead of generating content to return to the user, it performs actions. It has agency to act on behalf of the user. Now, agentic AI systems are more flexible than compound systems because the execution flow can now be determined by the agent. But fixed systems are set up at build time. But for that reason, compound systems can also be more reliable, but neither will replace the other. Like, you can expect to see various combinations of these approaches. So, digging in a little deeper, an AI agent, also sometimes referred to as an LLM agent, it's a program whose execution logic is controlled by an LLM using the tools it has at its disposal. So how it works is a user provides a query or instructions to the LLM. The LLM creates a plan to execute steps to achieve the goal specified in the prompt using these tools. Now, these tools, sometimes also called skills, because AI has skills now, they can be APIs, they can be a function you write, or even RAG. And not only does it execute these steps, but it can reflect on them and rerun tools using a feedback loop. So agentic AI has certain advantages, right? Such as the ability to support dynamic environments, use memory to improve upon past actions, and achieve some level of autonomy. But it also comes with some disadvantages, like it's less reliable. I mean, AI is still probabilistic, and it can still hallucinate. It can get stuck in these feedback loops. I've done that. AI agents are fairly resource intensive. And from a security perspective, it does, as with any new architecture, right, it introduces new attack vectors. And as you can see, this architecture has a number of moving parts, which can make it brittle and also complex to debug. Now, some say with agentic AI, today's front-end systems will become your back-end systems, meaning you won't need UIs anymore. But replacing a UI completely likely depends on the use case. So we covered the technical evolution of how we got here, but how does the value evolve? So with Gen AI, which is commonly driven through AI assistance, it's typically about information retrieval. Whereas we discussed an AI agent can perform tasks on your behalf. And in my opinion, for enterprise use cases anyway, do those tasks with some oversight, with a human in the loop. Now, most predictions in this industry indicate that this is going to evolve to multi-agent platforms, with some agents now calling other agents, along with more autonomous action taking. And you might have seen that some in the industry only consider multi-agent platforms as agentic AI, whereas a single agent is just an AI agent. But I'm not going to split those hairs, right? But from a value perspective, comparing generative on the left to agentic on the middle and right, Gen AI is reactive. It responds to a human's prompt, while agentic AI is proactive, potentially running autonomously. Instead of running prescribed tasks, it is goal-oriented, creating steps to accomplish a goal, and it's also reflective and self-correcting. So, how many here have used a chatbot, asked it a question, and were underwhelmed by the answer? Right? I can't see your hands, but I'm guessing a lot of people raise their hands, right? They are not always accurate. In fact, data here shows that the confidence in the accuracy of AI models remains low. In fact, only 1/5 of AI decision makers fully trust their models, 1/5, right? And if you didn't get an accurate response from an LLM when asking it a question, how comfortable will you be letting this LLM now take actions on your behalf? I mean, in particular, for certain use cases, this level of accuracy is just insufficient, right? Now, AI is not only less reliable than imperative programming, but it's also more expensive, and not even just from a hardware resource point of view, but I've seen a single prompt regularly use 3,000 to 5,000 tokens. For those who aren't familiar with tokens, AI models basically break down text into smaller units called tokens, which are roughly equivalent to one word or pieces of a word. And the tokens are what the LLM understands and processes during inference. And it's usually, and why this is important, it's usually what you get charged for when using a model. And at a high level, AI agents use more tokens because they're doing more things. Like they have to build a plan to accomplish tasks. And in some cases, they use the tokens to accomplish the tasks, like with a web search tool. So because agentic AI is less reliable and more expensive, we want to use agentic AI where agentic AI makes sense. And for this reason, I personally focused on use cases that are fit for purpose, which included those that may involve uncertainty, require some level of decision making, or that need to adapt to new information or changing environments. Now, we also want to ensure our use cases have value, of course, though I do believe there's a risk that the complexity of agentic architectures can create disillusionment as enterprises try to move those use cases to production. I mean, we saw this with Gen AI, where they wouldn't get out of POC to production. So to offset that, we want to focus on enterprise qualities of service that are required for production with those fit for purpose use cases, but meet enterprises where they are on this journey. So to that point, at least in terms of our own strategy, we're targeting work that you would perhaps assign to a human intern, something not so complicated to gain trust and capabilities, but is reviewable with a human in the loop. We're also looking at use cases that today are intractable, perhaps due to the level of scale of decision-making required, where the problem space is just too large to enumerate every path or every iteration is truly different. I mean, these are the things that aren't easily automated today, and therefore they're not getting done because of the manual work required. And then finally, agentic AI does amplify the security and operational risk. So we want to start with lower risk actions, those that an enterprise would be comfortable with, that can perhaps do no harm. And of course, we view it as table stakes to ensure that we've integrated the proper security, privacy, governance, and also transparency. So thinking about those factors, earlier this year when I was trying to build something and come up with use cases and figure out our strategy, I landed on this problem to tackle in the cyber resiliency space. A few years ago, a global fintech customer had asked me, how do I really know when I recover my data that it's a good copy and not corrupted, despite the fact that I'm even running a validation tool on it? There's this theme around provability, this lack of confidence that even running a single tool will truly ensure that you have data integrity and that your data is not corrupted. So either because of that, or in addition to that, often a manual verification is required. And this all leads to organizations often being unaware of how recoverable their mission critical data is. We observed there were other data recovery challenges, such as dynamic environments adding complexity. For example, microservices, especially those using persistent storage, can complicate the boundaries and scope of an application, making it harder to validate its data. And even if you have validation tools automated using imperative programming, it's hard to stay on top of when those tools are updated, and all of this can be tedious and even intractable for a human to do. And we saw there was this third theme around challenges due to the scale of recovery, right? Especially in a cyber recovery scenario. There's often this handoff between infrastructure and application teams for data validation. And of course, there's the usual constraints, as always, on staffing and expertise. And these are compounded by additional pressures due to regulations like DORA, which requires reports on provability of recovery at least once a year. So in general, cyber resiliency testing has not been getting performed, in part due to time and cost, and in part too, just because sometimes people often don't know where to start. But all of this is expensive at scale, making it hard to prove to stakeholders that your data and your applications are recoverable. So the use case I built for our fit for purpose scenario is, as a backup admin, how do I really know when I recover my data that it's a good copy and not encrypted or corrupted? And know this over time as my application changes. So the backup admin might say to the AI agent, tell me which tools I need to validate this recovery point and run those tools on the data. Now, this agent can go off and determine which tools make sense for the applications or workloads or data it discovers in the recovery point. It can go run the validation tools. And in the case of my POC, I set up MongoDB as the enterprise application. Now, keep in mind, we can also instruct this agent to also regularly search the web for new validation tools to add. And of course, we're providing the user the ability to also plug in their own validation tools, enterprise-specific tools, for example. But the value here is that the agent adapts to changing environments, and it opens up the opportunity to apply as many validation tools as possible to increase the confidence that the data is properly recovered. So just looking under the hood at the architecture, I created the following tools. I have a web search to identify common enterprise applications, though what I found with the model I used, it seemed to be trained well enough on this and actually gave better results than the web search. I created some tools to identify what applications are currently running, either by process name or ports used. I wrote a tool to call a built-in Mongo database function that checks a database collection for integrity and correctness. And finally, because I didn't want a backup admin to have to go check for results of an agent that may be set to run autonomously, I wrote a tool to send an email with the validation results. Now, I used, and what I'll show in the demo today is I'm using an LLM running in the cloud, but depending on your data regulation requirements, you may decide you want to use a model on premise. For model selection, you want to choose one that can not only predict and generate language, but can also generate and run function calling tasks. Not all models can do agentic flows, so it is important to pick one that does. Now, in the industry, these were starting to get called large action models instead of LLMs, though I mostly have just seen LLMs describe whether or not they can do function calling. So to build my agent, I used IBM's B AI framework, which is available as open source, and it allows for running models locally. In fact, BAI was designed to be a way for people to play with AI on your own laptops. Okay, so I also open sourced what I built, and there's a small group of us building it out to be more robust, but let's dive into the demo. So share my screen. All right, so everybody should see a PuTTY window up where I'm logged into a VM. So what I'm going to do is I'm going to run the agent with detailed output that I will show the mechanics of how the agent works, right? So I'm doing this intentionally so we can look and see how it works. But here I'm logged into a Linux VM that was recovered from backup. Maybe we're doing a cyber resiliency test, or maybe an actual incident happened, but we're trying to validate the restored data from our enterprise applications is not corrupted or encrypted. Now our agent sits inside the VM, possibly from a shared mem point, and or maybe from having been installed through Ansible. The VM is running a MongoDB database that is perhaps configured to start up automatically as the Linux OS comes up. And for let's take a look at the database. For our demo, we're using a database that has just 10 zip codes, just for a nice, quick, zippy demo, pun intended. So here we can see it has 10 zip codes, and then the internal validate function is this validate command, and you can see here, it tells you whether or not in the output your database is valid. Now, also, our agent is using watsonx Granite 3.8b instruct model, but you can see here in the commented out sections, you can plug in your own model or some other model. The other thing I want to show before I run the scenario is this window here. This is on the cloud side, I'm running watsonx.orchestrate, and this is where my LLM sits, and it shows the number of tokens that I've used over time here. So right now I'm at about 88,000 tokens, and I wanted to show this before I run it so we can see the difference after I run it. So let's just look at the code here quick, just to show you how the LLM would connect. So here's one of the tools, the MongoDB data validator tool, and every tool has a name and a description. The description is what the LLM uses to determine if the tool should be used. So it's in this description is where you want to put all the details to instruct the LLM whether or not this tool should be used. And what's supposed to happen, and what I've predominantly actually see happen, is that if the LLM can't find a tool that, to do a task, it will tell you. It's less likely to like make something up. It'll just say, I don't have a tool to do that, and it exits. And in general, this demo is a very low fidelity, right? It's just to show a proof of concept, even for the looking for processes. I'm just using the PS command for send mail. I'm just doing a shell escape and calling send mail command. So it's very low fidelity. Let's make sure I didn't edit it. Okay, so let's run this scenario. So I'm starting the agent, and pretty shortly here we'll have a prompt. We'll have a prompt to enter a prompt. And so you will see I have a very long prompt, and that's for a few reasons. First, I'm telling it to do a bunch of things at once. Second, because I'm not a prompt engineer, I found that with LLMs, the more detailed you are with your prompt, oh, it wasn't supposed to run it yet, but that's okay, I'll go back. The more detailed you are with your prompt, the more effective the results can be. And there are certainly pieces in that prompt I could have probably put in the system prompt again. So this finished, I'll scroll back up so we can go through it. So here's my prompt, and I tell it to identify enterprise applications that run on Linux and are most commonly used in the industry today, return a list with just the names of those applications, and check if they're currently running. If they are, and we have tools to validate that the data for those applications is not corrupt, run the validation, send an email with the summarized validation results. So part of it is I am telling it to do a number of things, but also part of it is I'm pretty sure the AI is training me on how to give it the right prompt for it. But as we can see, so what happens is the agent, it shows the framework, the BI framework shows the thought the LLM has. I mean, LLMs are really just next word predictors, but it's showing us in this interactive mode, to answer this question, I need to identify the enterprise applications that run on Linux. It kind of just repeats back to you, it parrots back to you in a way what you asked it to do. But more importantly, it's already working on trying to find the tools it thinks it's going to need. So here you can see it runs the find running processes tool, which if you're familiar with PS, you can see I just ran the PS command. And here's MongoD. Now we see this output twice because it also shows it returning the output back to the agent. Oops. So after it gets the output of the PS command of what's running, it says, oh, the list of running processes includes MongoD, which is a popular enterprise application that runs on Linux. So now I'll check if MongoDB data for this application is not corrupt using the MongoDB data validator tool. So here it calls the tool. Let's see if I can scroll. And basically you can see it has the same output like we saw earlier while we were in the Mongo shell. It sends that output back to the agent. The agent receives the output and it says, oh, the data for the application is valid. I will now send an email with the summarized validation results. So now it calls the send email tool. And you can see it says there's no output. It just calls a send mail command, as I mentioned. No results were found because send mail itself doesn't have any output, but the final answer of the agent is that the email with the summarized validation results for the MongoDB application has been sent. So let's check my email. Let's pull that over into the screen share. You can see I have a new email from my def sensor ID, and it shows that the MongoDB data validation results were valid. And this Text might look different. You can tell it to be more verbose. You can tell it to include the exact detailed output because you want to validate that. I've done that in prior runs. And so let's go take a look at our token use. Let me refresh this page. We're at 88,000 before we ran it. And now we're at 100,000. So it used quite a bit of tokens, more than 12,000. So I'm going to switch back, unshare the screen, and go back into the session, but that was the demo. Oops. There we go. All right. So the code I just showed you was built before this protocol called MCP took off. Now, MCP is one of the only agentic protocols that has gained traction or wide adoption in the industry. It's an open protocol. Think of it like the USB-C of AI apps. And it basically decouples the tools from the agent so that any agent can use any tool that's provided by an MCP server. Note that it also connects more than tools, right? It also normalizes how LLMs pull in data, and it addresses other flows, right? But as you can see here, if I were to implement MCP, which I'm working on, my agent would now have an MCP client tool that connects to one or more MCP servers. And also, instead of just having text descriptions of the tool to use for the LLM to use, tool information is wrapped in a standard JSON RPC format, which includes the description that we saw, as well as other fields like the input expected. But MCP is maturing rapidly. There are already over 4,000 MCP servers, but as of today, there are still some open questions and potential blockers to production around scalability, around traceability, and there are a lot of discussions going on about security best practices. But this is a very fast-moving space. Something that was, an open item a month ago is now not an open item, so watch this space. But you can minimally expect to see multiple MCP servers regardless, at least driven by the fact that the server is what actually invokes the tools, and some of those tools would need to be invoked on premise. So you might say, since MCP provides a way to take your existing APIs and make them available as tools to an LLM, why not take all your APIs and put them in an MCP server to make them available to your AI agent developers? Well, because what we are currently seeing is that once you get up to about 30 to 50 tools available to an agent, that exceeds the context window of the LLM. Now, an LLM's context window can be thought of as the equivalent of its working memory. And the size of the context window determines the maximum number of tokens that the model can pay attention to at any one time. So it not only contains information about the user's prompt, but it's used for keeping track of details of previous exchanges, adding extra enterprise-specific content like through RAG, or in our case, information about all of the tools available. And it even has extra data like the system prompt, which is what conditions the LLM's behavior and governs other aspects of the conversation. Like, for example, if you want to instruct the agent to respond politely. Right. So if an MCP server sends so many tools back to the client, back to the agent, that it exceeds the context window, the tool needed might not be included. And now the user has to have knowledge of which tools are necessary to perform the work, which defeats the whole purpose of using AI to pick the tools. So if you see a solution where someone has to provide in their prompt the specific Gorpy long API name and maybe some Gorpy API fields, and they're doing this instead of using human language, my guess is that's probably what happened. So you might say, well, why not just increase the size of the context window, right? Well, increasing the size of the context window can increase your compute requirements quadratically. It can slow down your outputs. And most importantly, like people, LLMs can be overwhelmed by an abundance of extra detail. Models take cognitive shortcuts. One study even observing that models perform best when relevant information is toward the beginning or the end of the input context. But defining the optimal amount of tools is ongoing work. For example, one approach is the creation of MCP rules, which associates keywords with tool metadata, but only clients that support the rules can benefit. So just watch this space. But my current thinking is that we'll want to scope each server's tools by either a particular persona or even maybe as granular as a particular set of use cases. So some factors to consider when evaluating an agentic AI solution from a vendor is what I've observed is that the frameworks today seem to target enterprises that are planning on building their own AI agents for their own business use cases. In other words, the builder and the consumer are in the same enterprise. But what happens when a vendor is shipping an agent to be run elsewhere in an enterprise? How do we as vendors evaluate success and debug on-site issues? Furthermore, is a storage or SRE persona going to feel like they now have to understand prompt engineering? So there is ongoing work to address how to get the answers you need with simpler prompts, some of that through system prompts. And with regard to vendors, my current belief is that vendors will likely need to test and certify their solutions with specific models to ensure somewhat consistent results. But for certain, and somewhat obviously, the value the agent provides needs to outweigh the work created. Now, from a security perspective, Agentic AI and MCP do introduce new attack vectors, but other aspects you may want to consider include what identity and authorization is the agent running under? Same question for the tools. I mean, is it that of the calling user? Is it some shared machine identity? How is this audited? You'll want to make certain it's appropriate for the use cases. Now, you also may want to just look at the specific tool's surface to the agent, right? For initial experimentation, maybe you want to start with tools that are, effectively read-only and do not, for example, alter the environment. But in general, ask yourself, what would a mistake look like? And if that happened, would that be acceptable? So you may want to start with simple use cases that do no harm, or at least ensure there's a human in the loop. So in summary, when considering consuming or building agentic AI solutions for enterprise, check if the use case is appropriate and provides value. If you look to the right, there are other factors I didn't explicitly discuss today, like latency requirements, but I put them here for your reference. You're going to want to verify the security characteristics, meet your requirements, and also understand how serviceability will be provided. I mean, it's a really interesting and exciting space. I've been having a lot of fun working on it, but most of all, I hope you found this session valuable. Now I've added some links here for your reference, and now we'll open it up for any questions.
Great. Excellent. Erin, thank you so much for that excellent information. And so we're looking for questions from the audience, and here's a couple right here. So the use case you chose seems fairly innocuous, but what are some of the risks we should be thinking about?
Yeah, that's a great question because as much as I talk about a do no harm situation and a read-only situation where maybe you're just getting data and not affecting your environment, it's technically really a do less harm situation because obviously if your data is not valid, you don't want an agent to tell you it is and vice versa. But I felt like this was a good starter scenario because the customer I spoke to he was already using a single data validation tool, but it wasn't enough in his mind. It didn't give him confidence. And when I looked at how to validate MongoDB, for example, there were 6 other ways I could have done it, right? So if I were to build all of them in, and if one of them makes a mistake for interpreting the results, like if the agent misinterprets the results, and the rest do not, that can increase your confidence in the results. And it also felt like a good candidate since it's more than the nothing many are doing today. But right now, we're not taking any automated action on the results. We're just trying to understand if the data is valid or not.
Awesome. Well, great. And another question is, What are some of the attack vectors specific to agentic AI?
Yes, I did mention that it does open up new attack vectors, and there's a lot of work going on in this space. OWASP has listed a number of the top ones, but a lot of the patterns look the same, but memory poisoning is one, which involves exploiting an AI's memory systems to introduce malicious or false data, to exploit the agent's content, which can lead to altered decision making or unauthorized operations. There's also tool misuse, which occurs when attackers manipulate the agents to abuse their tools through maybe deceptive prompts or commands. One tool misuse scenario is agent hijacking, where again, it's often when you're in a scenario where somebody can manipulate the data they send in and cause it to do some unintended action. And probably the security aspect of agentic AI could be a whole webinar by itself.
Awesome. Great. Thank you so much. And then let's see, what are other open areas that the industry has not solved yet?
Yeah, so I mean, I myself have really only been working on this since last December, and I hadn't really been even working on AI before this, truly. And one of the things I was looking into was how to evaluate success, right? How to know how to test an LLM. And in the industry, this is called evaluation. And Gen AI has LLM as a judge, where you use a second LLM to judge the first LLM's results. But I've not yet found evaluation models that validate execution plans, right? And the tool calling also needs validated. It's possible I've not just found it yet because this space is very fast moving, and I probably searched most recently a few weeks ago. But I suspect it has yet to be developed. I think the industry needs to catch up on this in this space.
Awesome. Let's see. Here's another question. When we build AI agent for customers, what is the percentage of acceptance to have the agent running in the target servers, which you had shown in the demo?
I'm not sure I understand this question. So when we build AI agents for customers, what is the percentage of acceptance to have the agents running in the target servers? I'm not sure what you mean by acceptance, percentage of acceptance. Could you elaborate on that, please, in the chat, whoever asked the question?
Yeah.
Take a minute here.
Yeah. Yeah, we appreciate your feedback. And if you could clarify a little bit better on the question, that'd be great.
Yeah, and even if we don't get to it today, if there's a clarification, we
Yeah.
can always try to address it in the follow-up blog. I mean,
That's right.
acceptance to me is kind of around a person accepting I can use an agent, and and I think that's still a lot to be determined. If people are, what people are going to be willing to try and accept. And I did run it. So, a lot of agent frameworks, they let you run the agent on your laptop, which I've also done. But obviously for my enterprise use case, I'm like, well, I have to run on an enterprise system, like in an enterprise VM, like that's where the agent will run because that's where it's going to do the validation, unless of course, all of my APIs were remote tools that could do it remotely. But in the cyber resiliency space, you're often in a clean room situation where you might have network isolation and it might not be so easy to try to run those things remotely. So I just took the approach that I made an assumption that the agent would be installed and running locally, thinking about that clean room scenario.
Yeah. Yeah, in some ways, I'm wondering if this is asking whether some of the AI agents would be distributed throughout the enterprise and be running on target servers, or is this more of a centralized task where I think your demo was acquiring data, essentially out of band from the servers that normally perform the workload, but it's essentially acquiring the data and then performing the integrity checks and things like that. So I guess
Yeah,
the question is, are you envisioning distributed AI agents that would go out to actual workload servers?
yeah. I mean, certainly there are multi-agent scenarios,
Yeah.
and obviously there's a lot of people who've done like an orchestrator agent to then manage other agents. But then now with MCP, there's this question of, is an agent really just a tool, and you don't need to have agent to agent communication when it's really just calling a tool? There's this whole set of architecture patterns that I think haven't really been worked through. And I see here that there's been a response. So if I understood the demo right, the agent was running on the Linux VM where the MongoDB is. The reason I raised the percentage of acceptance is because the production environment will not be allowed to have internet access. So, well, that's why I had the agent run locally, because I was expecting that there might be some network isolation versus, say, having it run outside of the VM and try to connect through the network. But it's possible I still don't fully understand the scenario. Oh, the questions about the LLM and whether or not the LLM should be local, then yeah, if you definitely, like even in the clean room scenario, it's likely you might be doing the LLM locally then if your network's isolated.
Yeah, that's an excellent question, and I think it touches on really the tactical use and tangible. How do you actually implement this in a data center with all the normal constraints with access to data, servers, privilege, and also I think you address some of the access levels, and are the agents at the same level as the user, or how do you manage that?
Right.
If you had any comments on that.
Well, I mean, I think there's still some ongoing work, and it's highly dependent on the use case, right? Of what authority you want the agents and tools to run under. But there's a lot of ongoing work in that space, including with MCP, to make sure that the right security levels are there. And yeah, just I feel like things change almost on an hourly basis in this space. It's really the rate of change of things happening is at breakneck speed. And so this session itself today is going to be outdated in probably a couple of weeks with some of the statements I made, right? Because it's just moving so fast.
Yeah, and we intend to have more webinars in a series, and we're organizing some of that right now. So definitely look for updates on SNIA channel, and that's awesome. Another question we see here, can you provide some reference links for someone starting new in agentic AI? I think you had a slide on that, and if you had some additional thoughts on resources.
Yeah, I mean, I put a link to BAI. Even though BAI is IBM, the reason I chose it is because they work with the community, and they actually just, I think, maybe a part of either Linux Foundation or some broader, governance model. But the reason I chose it is because I went to one of their dev day sessions that's open to the world, and it was about how to get up and running in a day. And I said, well, that's what I want to do. So I went and I listened to their session, and I was up and running just about in a day, right? So yeah, but even BAI has changed dramatically from the version my code is based on. They've since built in MCP. They have a TypeScript and a Python flavor, and I chose the TypeScript because at the time it was more robust, but now they're doing more investment on the Python side, even though they have both and they're still investing in both. But now the Python, I think, is at least equivalent and maybe surpassing the TypeScript side. And it's just changing so fast. And there's definitely other frameworks out there, and we're still even internally trying to figure out what are the frameworks we should be using for building agents.
Awesome. And then there's another clarification on the first question, on that question with the internet access. And you can see when we use LLM and we expect to search the internet to have the tools updated for various use cases.
Oh, yes. Okay.
Wouldn't this require internet access? Else will it not be left with outdated information?
Okay, I see what you're saying now, especially because too, I have the web search tool, so I got you. So yeah. So what was interesting was I had stopped using the web search and was just using the model because I felt like the model was giving me more information. But realistically, what I would probably do for a more enterprise approach is hook into APIs that an enterprise might be using has their like software asset inventory, right? That's going to be way more reliable than me just guessing based off common internet applications. And now whether or not that's blocked because it's internal, I don't know. Like, I think it will depend on your specific environment and also the use case of a clean room. So it could be possible that in such a clean room scenario, we would have to make it a bit more robust and maybe have some sort of persistent memory around typical applications or do something different. So yes, that's all valid.
Awesome. And then another question, is the Watson X a platform to build agents? For example, is it similar to Flowise type platform?
Yeah.
Flowise, excuse me.
Yeah. So yes, Watson X. In fact, this session isn't about a specific vendor, nor is it meant to be vendor specific. But they have a low code agent builder in here, which I started with playing with, and I don't have the link immediately available. And again, I shouldn't show something probably vendor specific anyway. But yes, Watson X has the ability to build agents. The reason I didn't choose the low code version here is because I knew I wanted my agent to run on-prem, and I felt like the low code one would be running from the cloud, and that just didn't meet my use case.
Awesome. Great. And then let's see, you mentioned earlier that there's the ability to improve upon past actions. How much training is needed initially and versus longer term, just as far as the user being able to tweak the model and kind of dial it in to get the right accuracy?
Yeah, so the ability to act upon to improve upon past actions isn't so much about training. It's more about that context window and the size of that context window and the amount of stuff you fill it with. So you'll have the context window again is like the working memory for your LLM. And if you blow through that context window with a bunch of tool information, you're going to push out the information about past actions. And so it's kind of more of a context window tuning problem than a training problem.
Awesome. Great. And do you want to put up that slide that showed the reference links just briefly? Yeah, and then let's see, what we could do is spend a little bit more time on the Q&A blog and just look for other resources
Yep.
we might want to add to that.
Yep, definitely.
Great. Let's see, that's all the questions I see in the chat. And do you have any kind of thoughts or closing remarks as far as the whirlwind activity? Because I know you've really jumped in and done this so quickly. And as far as getting your hands into the tools and the code, any insight as far as helping folks understand the context for getting on board?
Yeah, I mean, so it is a highly, rapidly evolving space. It's a very exciting space. In the CTO office, that's a strategy role. I was tasked with working through our strategy, which I'm articulating across our product teams for storage, at least in some cases across infrastructure. And so I'm happy to come. Like, we have customers, I go talk to them. I'm happy to come, talk to them about approaches, and I still myself don't even have all the answers. It's a very evolving space, but it's a very exciting space. So just feel free to reach out to me on LinkedIn if you want to have any further discussions. And we'll see how I can help.
Awesome. Thank you so much. And I don't see any new questions there, so I think we can conclude. And thank you so much, Erin, for your exceptional expertise and incredible insight. And this has been a fantastic discussion with lots of great information. And I really appreciate all your time and effort on this. And we look forward to more webinars coming up. And thank you to our audience. Thank you for joining us. Please remember to rate this webinar, as this is very important to get your feedback, which helps us create better educational material. Also, please remember you can download this presentation and many other items at our educational library, as well as follow us on X. Thanks again to all one more time, and have a great day.